Alright, say I ask you to classify all groups up to isomorphism of order 65. So, let G be a group of order 65. Well, 65 is equal to 5 to the power 1 times 13 to the power 1. Note, these are primes. By Clos's theorems, we have there exists an element in G of order 5, call it A in G. Similarly, there is an element of order 13 in G, call it B. Notice that the LCM, the least common multiple, of 5 and 13 is simply their product. But since G is a group, AB is in G. But then the order of AB is equal to the LCM of 5 and 13, which is equal to 65. But then AB generates G, hence G is cyclic. Thus, all such groups of order 65 must be cyclic groups up to isomorphism of order 65.